Hello and welcome. Let's solve another interesting question. Say 9 to the power of x minus 9 minus 9 to the power of y minus 9 is equals to 6,560. So we are asked to find the value of x and the value of y. Alright, for us to solve this question, we are going to recall from the law of indices that says if we have a to the power of x minus y, it's going to be equals to what? A to the power of x all over what? A to the power of what? A to the power of y. Is that clear? All right. So now if we apply that here, so let's rewrite the question first. We have 9 to the power of x minus 9 minus 9 to the power of y minus 9 equals to 6,560. All right. So now if we apply this law here, we are going to have 9 to the power of x all over what? 9 to the power of 9 minus 9 to the power of y all over what? All over 9 to the power of 9 equals to what? 6,560. Alright, so if I multiply through by what? By 9 to the power of 9. It means 9 to the power of 9 we multiply what is here. We are going to be left with 9 to the power of s minus 9 to the power of y to be equals to 9 to the power of 9 multiplied by 6,560. Alright. Now, you are going to observe that 9 to the power of s minus 9 to the power of y here. If we subtract these two numbers, we are having a positive number here. It means that 9 to the power of s is greater than 9 to the power of y. And it also means that s is greater than what? Y. Is that clear? Alright, so if this is true, we can therefore say, let's assume our s to be equals to y plus a constant number, which is k. Alright, so now we are now going to substitute y plus k for what? For s in this equation. So it means we are going to have 9 to the power of y plus k minus 9 to the power of y to be equals to what? To be equals to 9 to the power of 9 multiplied by what? Multiplied by 6,560. Alright. Now, again, we are going to recall from the law of indices that says if we have a to the power of s plus y, it's going to be equals to what? A to the power of s multiplied by a to the power of y. So if we apply this, we are going to apply this here. So we are going to have 9 to the power of y multiplied by 9 to the power of k minus 9 to the power of y to be equals to 9 to the power of 9 multiplied by 6,560. Alright, so if we look at this carefully, you observe that 9 to the power of y is common. We factor it out. So we are going to have 9 to the power of y into 9 to the power of k minus what? 1 equals to what? 9 to the power of 9 multiplied by what? 6,560. So by equating the left hand side with the right hand side, it shows that 9 to the power of y will be equals to 9 to the power of 9. And 9 to the power of k minus 1 will be equals to 6,560. So we are going to have 9 to the power of y to be equals to 9 to the power of 9. And then 9 to the power of k minus 1 will be equals to 6,560. Alright, so from here, you observe that the base here we cancel out them. The value of our y will be equals to what here? 9. Alright. So if I move this 1 to the other side, 9 to the power of k will be equals to 6,560 plus what? Plus 1. So it means 9 to the power of k will be equals to 6,560 plus 1 will be equals to 6,561. And you are going to recall carefully that 6,561 is the same thing as what? 9 to the power of 4. So we are going to have 9 to the power of k to be equals to 9 to the power of 4. So again, this base will go with this base, then k will be equals to 4. Alright. So now that our k is equals to 4, we can find the value of our what? Our y. Because we know that from this equation, we know that s is equals to what? Y plus what? Plus k. Alright, so if we substitute for s, the value of our y is what? 9. So it means that s is equals to 9 plus k, which is what? 4. So it means that s is equals to what? S is equals to 13. So it means the value of s is 13 and the value of y is 9. If you want to verify, you can come and substitute for the value of s and the value of y. Then you perform your analysis, you see you are going to have this. I want you to try that and tell me if that is correct in the comment section. Thanks.